All right, guys, this is Dr. Callahan for Algebra 2, Semester 2 for week 3, Wednesday. This is your warm-up, so pause the video and answer the following questions. Happy Wednesday. All right, so if you are not here for the course request, these are the following possibilities of classes that you should be taking after Algebra 2. You have option 1, 2, 3, and 4. And so make sure you make a decision as to which class you want to take, and then let me know so I can tell your counselors. So when you become a senior after this class next year, you can either go into Algebra 3, Prop and Stat, Intro to Pre-Calculus, and Trig and Pre-Calculus. Obviously, the class on the right is a more difficult one. The one on the left is the easiest, and then everything in between is based on the level of difficulty from left to right. All right, so today we are going to go over your transformation of polynomial functions. It's our first day talking about this. So these are the materials that you guys are going to need. On the start transformation of polynomial, you are going to take your week 3 assessment today in class, which I'm going to give you guys a little bit of time towards the end. You do need, however, a TI-84 calculator, and you also need to have color pencils. So you guys come on up. Grab your TI-84 calculators, and I have an entire thing of colored pencils right here because we're going to need it. And so grab a entire thing of colored pencils as well, please. So don't be shy. Come on up. Grab this, and then grab a donut if you would like a donut. And if you can please put your TI-84 back, that will be great. I will really, oh, you just take the whole thing. Take the whole thing. Yeah, take the whole thing. You're not taking one pencil, you're taking the whole thing. All right, so you should have this. We're going to talk about transformation of cubic functions. Now, you have your color pencils. Take out 3 color pencils, or I should say take out 5. You can take one at a time if you want. So this is your cubic transformation function, okay? And obviously these letters, that is A, B, C, and D, they all obviously mean something. And so we're going to fill out those little boxes so that you know what they mean. Okay, so let's start off with D. For the D, if it's a positive D, that means your graph is going up. And if it's a negative D, that means that's a number of units, your graph is going down. Does anybody else need the clipboard for your course request? 1, 2, 3, 4. Anybody else need one? Okay, now that I have it, this is what I'm gonna put in there. I like the fact that some of you guys are gonna try number 4, that's good. I think you guys will do really well in trigonometry and pre-calculus. Okay, then I'm going to take a look at C, okay? So C, you got to be careful. It is going to be opposite, okay? So I'm just put opposite with a exclamation point. If it's going to be a negative C, I know you want to think going to move to the left, but you're not moving to the left. You are going to move to the right. If it's a positive C, this is how many units you're going to move to the left. It's opposite. Okay, next thing we're going to take a look at is going to be that A right there. This A is going to talk to you about a vertical stretch, okay? So think about your graph. And if it's gonna be a cube, anything with an x cube is gonna look something like this, okay? And imagine if I was like stretching this vertically, okay? So if you stretch it, could you imagine if I were to stretch it farther up? If I stretched it really far up, do you see how much longer and compressed it is, like skinnier? And then if I pushed it down, like if I actually, this is the first one here is saying that if I were to stretch it up and down, okay, that way. Now, on the other hand, if I went ahead and pushed it down this way, then what will happen to my graph is that it will be, I would think it will be like a little bit wider. Do you see that? Okay, so that's the difference. And that A will tell you that, because if A is going to be bigger than 1, it is going to be skinnier. And if A is smaller than 1, it is going to be wider. Another thing that you should know is that plus and minus, okay? If your A is going to be a positive A, it is going to look like in this direction, okay? If it's a negative A, you will have it like in this direction. You see how it kind of like flips a little bit? And all it did is it is reflect about the y-axis. And so if you're like, well, what does that mean if you put it together? So if I were to draw a grid right here, okay? And my parent function is y is equal to a positive x cubed, my graph will look something like this, like I have it right here in purple, okay? Now, on the other hand, if my y is equal to a negative x cubed, this is what my graph will look like. You see how it is flipped about the y-axis, you just flip it, okay? So use your 2 different colors and make sure you draw that so that way you know this is what it looks like. All right, so then let's talk about B, which is going to be literally your last one there. So for B, if B is bigger than 1, it is going to be a horizontal compression. So horizontal compression. And then if B is going to be less than 1, it is going to be a horizontal stretch. So compression just means shrink, you guys, okay? So if B is less than 1, it is going to be a horizontal stretch. So it's going to be wider. Now let's talk about the domain and the range. Okay, just looking at this right here, your domain are your X values. Okay, your domain could literally be any number that's going to be between somewhere in X. Okay, it's going to be a specific number. And, you know, like this one right here, it might be at -3. This one may be a +3. So depending on how wide and skinny your graph is, it could be at 3 or 2 or 8 or 100. Okay, but there's going to be a definite specific number. Your range, do you guys see the little arrows that's going up and down here? Range are your Y's. Okay, your Y's are up and down. So do the arrows ever stop at a specific number on the Y-axis? No. So your range is going to be from -infinity to +infinity. And there are several ways of writing this. You can write it as -infinity, comma, +infinity in parentheses, or you can write all real numbers. These three ways, they all mean exactly the same thing. Oh, excuse me. Yeah, it's just sign up. Okay, so now that you guys have this, it's good to have, because now we're going to go ahead and like jump in and do some of your notes that will help you with this. Okay, so let's take a look at this part. You guys have this one on top, right? Let's fill this part out. So transformation, adding a value to the variable of the function causes the graph of the parent function to shift. So keyword is adding. So if you're going to be adding, where are you going to shift it? Shift up, obviously. Similarly, if you're subtracting a value from the variable of the function, it causes the graph of the parent function to shift down. On the other hand, if you're gonna, oh, you know what? I totally screwed this up. I'm sorry. Okay, I screwed this up because I didn't see the parenthesis right here. Do you see the parenthesis right there? So for adding a number, it's gonna shift over to the left. That was my bad. I apologize. And then if it's a -k, but it's inside the parenthesis, it's gonna shift the graph to the right. Sorry, that was my fault. I apologize. But in this class, if I ever do make a mistake, and in all of my math classes, this is my 18th year teaching at Hug. So 18 years ago, you think about it, you guys were not even born. You guys were not even created yet. I don't think anybody here is 18. So you guys, I don't know, your moms might have been pregnant with you barely. You are not even like barely, I don't know, an egg or something. But yeah, I've been here for a very long time. So every time if I do make a mistake, I don't ever try to hide it. I'm always very honest. I'm like, and look, I'm a human being. I make mistakes, and I always try to like model by example, because if I make a mistake and I'm like, it's okay to do that, then hopefully my kids or my students will know that it's okay to make a mistake, you know, own up to it and then just correct it next time. If you're adding a value to the function, it causes the parent function, like this +k, notice that's outside of the parenthesis, to shift up. And then similarly, if you're subtracting it, it's going to be shifted down. All right, if you have a negative, multiply the function by a negative, cause the graph to reflect across. What just happened here? Hold on. No, I don't want that. I'm not quite sure what just happened here. What just happened? hold on a second about that. All right, so everything got lost before this, but that's okay. So this negative right here just means that you're going to reflect about the x-axis, and then if that negative is on the inside of the parenthesis, you're going to reflect about the y-axis, and then that a right there, which is right here in front of it, multiply the function by a number between 0 and 1 causes the graph to, so it's between 0 and 1, a is smaller than 1, obviously, it's going to cause it to be wider or more compressed. Okay, and then opposite of that, if you're multiplying a number greater than 1, so a is bigger than 1, then it's going to cause the graph to be skinnier, or I guess I should say more stretched. Okay, so now that you guys have the part 2 transformations of a cubic function, let's go over some of the notes that's affiliated with this. So go to your white packet. And we'll get started right here on 3.7 on transformation of polynomial functions. So for those of you guys on Zoom with me, this is what you should have filled out from the last part. So pause the video if you need to. And then we're going to go on to your guided notes on 3.7. All right, so why is knowing the graph of a parent function a valuable tool? Graph the parent function of a cubic function for f of x. So with your graphing calculator, and you're going to be doing this on your graphing calculator. So here's my graphing calculator. And I'm just going to go to y is equal to, and I'm just going to hit x, which is right there. And I'm going to hit that little caret button, that little triangle. So you can do a cube, and you push 3. Now, if you're like, I don't really like touching that little caret button, another way you can do this is go to math, you guys. If you go to math, go down to number 3. Do you see how number 3, there's a cube button under math? So there are 2 different ways that you can do that. And then hit graph. Now, if your graph doesn't look like mine, you might want to go over to Zoom, go down to number 10. To zoom fit. So number 10 is zoom fit, hit enter. And I'll graph it so it fits the whole thing on your screen. And now what I want you guys to do is just draw that graph on your grid. Thank you. I have your report cards for those of you guys who didn't get it. I think they finally figured out that someone went over to more people. Savannah, are you here today, Savannah? I have yours, my dear. You have 2. Lucky you. I think they're exactly the same one, but it's for both of your parents. So if I were to go ahead and graph this, I will go ahead and just have it so that my graph will just look something like this. And that's the general shape of the parent function. Keep in mind that this is called the parent function because this is the original. Once I start adding numbers, you always start from the parent function, and the parent function is always at the middle of 0, 0. Okay, so I'm going to start adding a few things. So with your different color pencil, if I do f of x is equal to, and this is my first add-on, if I do x cubed minus 4, okay, what that means is I'm going to go 4 units down. So I'm going to go down 2, and here's 4. And then this is going to be my new graph. So you want to graph yours like mine as well. So you just move down 4. Now, the other hand, if I decide to go ahead and do a second one, so I put f of x is equal to x squared plus 5. That plus 5 means you're going to go up. So here's 4, here's 5. I put the dot right there, and I'm just going to draw my line. And I just shifted 5 up. Now, similar to that, I can also move around a little bit more, like my third one. If I do f of x is equal to x minus 6 cubed. So I put a square, I meant cubed. There we go. So x minus 6 cubed. That means it's 6 to the right. So I'm going to go to 2, 4, 6. Start right there. And my graph will look something like that. So you just shift it over to the right 6. And the very last one, actually maybe not the last one, got 2 more to go. If f of x is equal to x plus 6 cubed, you guessed it, you're going to go to the 6 to the left and then draw your graph like that. All right, so let's go ahead and take a look at this part here. HK form of cubic. HK is kind of the point in the middle, okay? How are g of x equals x and f of x equals x cubed similar, and how are they different? So in order for me to figure that out, let's go ahead and graph this. So on your graphing calculator, you already have x equals x cubed right there. And do you see how it is like blue? So when you guys go ahead and have that, the graph will look like it's blue. Now, where it's red, I'm going to put just x. So you're just going to type in x, okay? So you have x cubed and then x on your graphing calculator, and you're going to hit graph, and you're going to graph both of them. And I know you're like, it looks like that X is like, you know, kind of flat. So let's go over to the windows and let's make sure we change that. And the reason why it's flat is because if you look down over here, your Y min is at negative 1,000, and we don't want that. We want to change it to a negative 10. And by negative, you don't want to push the minus button. You want to push the negative. The negative is that little red button on the very bottom. Okay. Negative 10. And we're going to put positive 10. So window, and then make sure you have negative 10, positive 10, and then hit graph. There's your blue. And there is your red. So what we're going to do here is I'm going to go back to this, and we're going to go ahead and draw it. So here's my grid. My blue graph is going to be the x cubed. So my x cubed looks like this, like that. Okay. This point right here is at 0, 0, and that is h comma k. And then your red graph, which is just x, is just going to simply go straight through it like that. And that's what you should have. All right, so then I want to go down over here. Describe the transformation of what is being done over here, okay? So when I say describe the transformation, I literally want you guys to write it in words. And so you're going to have your lines right here. And tell me, is it going up, down, right, left? Is it reflected? Is it skinnier? Is it wider? What is it? So take a moment and do that, please. Now, just based on what I see here, I could say that this 2 means that you're going to go 2 to the left. The 1/2 means that A is smaller than 1, so your graph is going to be wider. And because it's a negative, you're going to reflect about the y-axis. So if I were to go ahead and graph this from this graph, I would go over 2 to the left, so 1, 2. And from this point, I'm not going up or down because there's no numbers after the parenthesis. It's going to be reversed, but it's going to be a wider shape. So it's going to be like that. And that's what it will look like. All right, guys, we're going to get out of here in about like 1 minute. So what I would like you guys to do